Okay, today we are learning about graphing piecewise defined functions and shifting and reflecting graphs of functions. I know I've got this when I can graph piecewise defined functions, apply vertical and horizontal shifts to functions, and reflect graphs. So you can see we're going to be doing some transformations. Key vocabulary is a vertical shift, a horizontal shift, or a reflection, and piecewise functions. So piecewise functions are literally just pieces of functions. So we're going to be doing linear piecewise functions, so pieces of lines. Okay, so evaluate f of 2, f of -4, and f of 0 for the function f of x equals 3x plus 1 if x is less than or equal to 0, and x minus 4 if x is greater than 0. Okay, so here's what we're going to do. So f of 2. So that means that x is greater than 0 because x is 2. So all I have to do, these are called domain restrictions right here. So basically you see where your x, because it's f of x, right? So x fits in. If it's greater than 0, you're going to use this function. If it's less than or equal to 0, you're going to use the first function. So I'm going to say f of 2 equals 2 minus 4, which is -2. So that that ordered pair, I'm sorry, is going to be 2, -2. All right, if I use f of -4, -4 is less than 0, so I'm going to use the first function. So 3 times -4 plus 1. So you see, I'm just substituting x with whatever I need to in the function. So that would be -12 plus 1, which is -11. So that ordered pair is going to be -4, -11. And then for the last one, f of 0, I'm going to use the first function because it says x is less than or equal to 0. So I'm also going to use the first function for that. So 0 plus 1 is just 1. So that ordered pair would be 0, 1. And those are my answers. So I've got all that. Okay, 1b says evaluate all the functions for this function. So just like we did in the first one, so you have to decide which function to use. Okay, so for f of 2, 2 is greater than 0, so I'm going to use the second function. So I'm going to say -2 minus 1 because I'm using this because 2 is greater than 0. So when I do that, I get -3. So that order pair is going to be 2, -3. Okay, then I've got f of -6. So -6 is less than 0, so I'm going to use the first function. 2 times -6 plus 3. So I get -12 plus 3, and it's -9. So that ordered pair would be -6, -9. The next one, f of 0, I'm also going to use the first function because it says or equal to 0. So 2 times 0 plus 3 is 0 plus 3. So that ordered pair is 0, 3. All right, this is one for you to do, so go ahead and pause the video. And you should have gotten 4, 5, -2, 6, and 0, -2. All right, now we are going to graph piecewise functions. Okay, so we are graphing pieces of functions. So here's how I'm going to tell you to do it. You're going to graph each piece separately. So like this is one piece, y equals 3x minus 1. And this is the second piece, y equals x plus 3. All right, so how do we do that? We're going to graph each piece. We can plug in points. And then you're going to see both of these tables, okay? So the first one, f of x equals 3x minus 1. I'm going to use a closed circle where x is 0 because it says or equal to 0, okay? So again, I'm going to use a closed circle. Whoops, sorry. I'm going to use a closed circle because I have equal to 0. On the second one, I actually should have plugged in a 0 here. If I plugged in a 0, I would get 3, and that would be an open circle at 0, 3, because it's not equal to 0. It's just greater than 0. Okay, so on the next slide, remember I said right here, this one should have a 0 and a 3, and that should be open. Okay, so what do? You plot the domain restrictions. So the function, let's see if I can remember it. It was f of x equals 3x minus 1 if x is less than or equal to 0, and then x plus 3 if x is greater than 0. Okay, so that was the function that we're graphing. All right, so how does this work? You are going to start at your domain restriction, okay? So I'm going to start at 0 for both of these. So on the top one, it's 0, -1. So I'm going to put that closed circle here, and then I'm going to plot -1, -4, and I'm going to go in that direction. For the second one, I'm going to start at my domain restriction, which is 0, and that's going to be open circle because it was greater than, not equal to. And then I'm going to plot 2, 5, and 3, 6, and I'm going to go in that direction. That is how you plot a piecewise function. All right, so let's do this one. Let's graph, then list the domain and range. All right, so if we have g of x equals x plus 2, where x is less than 0, and negative x plus 2 if x is greater than or equal to 0. Again, I really like having a 0 in here also. I really do. So if I did that, let's see what we would get, okay? So we're going to plot these points. Well, we're not going to plot them first. We're going to write them in the table. Okay, so here, I'll back up and I'll do it with you. All right, so I said I like to start at the domain, right? So I'm going to say if x equals 0, then y would equal 2. If I plug a -1 in here, then that would be 1. If I plug a -2 in, 0, -3 plus 2 is -1. Okay, now I'm going to start with the second one, starting at the domain restriction. So if x equals 0, y would equal 2. If x equals 1, that would be -1 plus 2, so 1. If x equals 2, -2 plus 2, that would be 0. Now you're going to plot these points, starting at the 0, okay? So 0, 2, I'm plotting the first one first. Okay, so 0, 2, that's going to be open circle because it is not equal to 0. It's just at 0. -1, 1. -2, 0. -3, 1. So that looks like this. Now let's do the other part of the line, okay? So you've got 0, 2 is a closed circle, 1, 1, and 2, 0. And we're going to go that way. So that is what the graph looks like. Now, I know that some of you are probably thinking about this point right here in the middle. If a closed circle and an open circle overlap, the closed circle wins. So it becomes a closed circle. All right, and then you can see I graphed it again. The domain on this, it says list the domain and the range. Since this is forever going to the left and the right, the domain is all reals. The range, you are starting where y equals 2 and you're going down, so it's less than or equal to 2. And now you get to do one. So pause the video. And this is what it should look like for you. All right, if you wanted to list the domain and range, what would that be? The domain This is forever going to the left and the right, so that would be all reals. The range, though, it goes forever down this way and forever up this way, so that is also going to be all reals. Okay, here are some common graphs. You've got the linear graph, a quadratic graph, a radical graph, and an absolute graph. So I want you to look at the symbols and write all these down. Go ahead, you need to write these down in your notes. All right, so some vertical shifts. If you have a plus k, so plus a constant out to the side, that's going to shift upward. If it has minus, that's going to shift downward. If it's in a parentheses or inside a function, it's going to shift to the right. If it's minus, if it's plus, it's going to shift to the left. You should also write that down if you haven't already. Okay, so here's some examples. So graph f of x equals x squared and g of x equals x squared minus 3. And then you kind of need to know, like, how are they different from each other? Well, I can tell you without graphing anything, this one is going to be 3 units down because it has minus 3 out to the side all by itself. Okay, now I also know that x squared means that that is a quadratic graph, so it looks like this. So if I'm graphing down 3, 1, 2, 3, it would just look like this. So watch. There are your graphs. That's all you have to do. Now, if you want to get specific numbers, you can plug in numbers for x into both of these. And just like we did on the other graphs that we were doing. So you can do x squared here and x squared minus 3. And so just plug in some numbers, like do -2, 0, and 2. So right here you would get that squared would be 4, like this. And then if I subtracted 3 from that, I would get 1, 0, and 1. So you see how they're coming up with those points. All right, 3b, we're going to graph this one. Okay, so tell me what you think. How is f of x different than g of x? Or how is g of x different than f of x? You're going up 4. Okay, so we're going to actually plot this. So I'm going to plug in some points for x squared. And then I'm going to plug in some points for x squared plus 4. All right, so let's come up with, I don't know, let's do 2 again. So -2, 0, and 2. Those numbers don't matter, by the way. You can do any numbers you want. So -2 squared, -2 times -2 is 4. 0 times 0, 2 times 2. Now you're going to add 4 to all those. So you would get 8, 4, and 8. Now we're going to plot them. Okay, so I've got -2, 4, 0, 0, and 2, 4. So this graph and a parabola is a graph of a quadratic equation, and it's curved. And it kind of looks like that. It's kind of sad, but that's kind of what it looks like. All right, and the next one is -2, 8. -2, 8, 0, 4, and 2, 8. And you can tell by looking at those that g of x has moved up 4. All right, now you're going to do this one. Well, actually, no, we're going to do it together. I'm sorry. Okay, so since the 3 is inside the parentheses and it's plus, I know that if it's inside and it's minus, it's going to the right 3 spaces. Okay, so instead of f of x going like this, g of x would go to the right 3 and look like that, 1, 2, 3. Okay, but let's plug in some points so I can prove it to you. All right, so we have x squared and then we have x minus 3 squared. Okay, so let's just use the 2's again. So -2, 0, and 2. So if I squared that again, that would be like this. Now, if I did the inside parentheses, so that you've got -2 minus 3 squared, what would that be? that would be 25. And then if you have, well, you know what? I don't like that because we know that it's going to the right 3. That's why these numbers are kind of crazy. So I'm going to back this up for a second. And I'm going to say, I know that it's going to the right 3. So instead of using the same numbers for x, I'm going to use some different numbers. All right. So I know the first one centers at 0, right? Because that is the parent graph. That's the original graph. So if I know this is scooting over 3 to the right, I'm going to make 3 my middle number. And I'm going to do 1 and 5 on either side. So 1 minus 3 is -2, squared is 4. 3 minus 3 is 0, squared is 0. 5 minus 3 is 2, squared is 4. Now what do you see? All right, let's plot this. So I've got -2, 4, 0, 0, and 2, 4. Okay, so that's the original. Now we're going to get a different color and I'm going to plot these. So 1, 4, 3, 0, and 5, 4. And you see that the g of x is moved over to the right 3, even when I plug in those numbers. All right, now we're going to have an absolute value graph. So an absolute value graph is a V. It's not a U, it's more of a very strong V. So I know that if I have +2 inside the grouping symbol, that's going to go to the left 2. So instead of being centered, you're actually going to go to the left 2. So this is what this looks like. There you go. And you can always get specific numbers by plugging in specific points by plugging in numbers. So watch, if you wanted to graph the first one, let's just say, let's do -2, 0, and 2, since that's worked for us. All right, what is the absolute value of -2? 2. So this is how they're getting like -2, 2, 0, 0, and 2, 2 for the original. And then if you moved that to the left, you would get the blue line that you see. All right, so we're going to graph this one. How is g of x different from f of x? You have -5, so you're going to go to the right 5. Okay, so let's actually plug in some numbers this time. All right, so for f of x, we've got it equals absolute value of x. So I said if we did 0, -2, 0, and 2, it would look like that. So we would have a point here, here, and here. And I would graph it like that. But I really want to show you what happens when you translate it to the right 5. Okay, so if I picked some numbers, remember I'm going to shift to the right 5. So instead of having my center number at 0, I'm going to have my center number at 5. And then put 2 numbers on either side of that. Okay, so 3 minus 5 is -2. The absolute value of that is 2. 5 minus 5 is 0. Absolute value 0. 7 minus 2 is 2. The absolute value of that is 2. So now I'm going to plot these numbers. So 3, 2, 5, 0, and 7, 2. And then I'm going to graph it. And there you can see it is shifted to the right 5. All right, you go ahead and do this one. And you should have gotten that. So this translates down 6. All right, number 5. Now we have a radical graph. Okay, so a radical graph looks like this. From your notes that you took down, you should have that. So if you have -3 inside the grouping symbol, that's going to go to the right 3. So it actually, instead of starting at 0, 0, it'll start at 3, 0, and it goes like this. So Let's show you what that looks like actually. So if I have 0, hang on. There we go. The square root of that would be 0. If we have 1, the square root of 1 is 1. If we have 4, the square root of that is 2. Okay, so this graph looks like this. So if we go to the right 3, we want to notice that by putting in points, right? So I'm going to start at 3, but that's the square root. Let's see, we would have x minus 3, so 3 minus 3 is 0. If we did 4, 4 minus 3 is 1, the square root of that is 1. And if I did, let's see, 4, so let's say if I did 7. 7 minus 3 is 4, the square root of 4 is 2. So I'd have 7, 2, that's not even on the graph, but I can show you what these would look like. So it would start off like this. So you can see that it's shifting to the right 3. All right, 5b, we're shifting to the left 1 because we have plus 1 underneath. So if the original looks like this, then the translated version, we're going to shift it to the left 1. Let's see, if I put in a 3, let's see, if I put in a 3 for x and I have x plus 1, that would be 3 plus 1 is 4. So the square root of that is 2, so that's correct. So this would look like that. So we're shifting it to the left 1. Okay, now you do 1. All right, and you should know that it goes down 3. So whereas this one goes like that, this one would be shifted down 3, 1, 2, 3. And it would look like this. All right, reflections. When you have a negative in front of the function, that means it's reflected about the x-axis. So watch, if I do this problem. Okay, we got a lot of transformations going on here. So this is actually a very important lesson with all these transformations and graphing, so I really want y'all to pay attention. If you have a negative in front, that means it's reflected around the x-axis. Okay, so that means instead of going up, it's going to go down. And then you have the 2 inside the grouping symbol, which means that you're going to go to the left 2. And the negative 1 outside means that you're going to go down 1. So let's see. So we have the original, remember, absolute value graph just looks like this, right? But now we're going to go to the left 2, so 1, 2 to the left, 1 down, and then this is actually wrong because it's going to be reflected down like that. So my graph is correct. You go to the left 2, down 1, and then reflect it over the x-axis. All right, 6b. So this is another absolute value graph that we're reflecting. So the negative 3 means what? To the right 3. The plus 2 means what? Up 2. The negative sign means reflect over the x-axis. All right, so instead of going like our parent graph, we're going to go to the right, 1, 2, 3, up 2, 1, 2, and we're going to reflect, which means that it's pointing downward now, so it looks like this. Now, if you want to, we will, just so you'll feel better about it, We can come up with points, okay? So I'm just gonna do 3. All right, we know that this is going to the right 3, right? So that's gonna be our middle number. Now I want numbers on either side. So I'm gonna say a 1 and a 5. All right, so if I have negative 1 minus 3, the absolute value of negative 1 minus 3 plus 2. All right, so this would be negative 4, so a positive 4, but you have that negative sign out in front. That would be negative 2, right? So 1, hang on, let's see. I didn't want to do that. All right, so I'm erasing this. Okay, so you've got, let's plug the 1 in, not a negative 1, a positive 1. Okay. So let's try this again. We have negative 1 minus 3 plus 2. What's 1 minus 3? Negative 2. The absolute value of that is 2, but you have this negative sign in front. So negative 2 plus 2 is 0. So let's plot at 1, 0. Now 3. So 3 minus 3 is 0, right? Plus 2 is 2. So I'm going to go to 3, 2. And then if I have a 5, I'm going to say 5 minus 3 plus 2. So that would be 2. So negative, because of this negative sign, plus 2 is 0. So 5, 0. And I have what I thought I was going to have. So again, let's check it. We're going to the right 3, up 2, and we reflected it downward. Now you get to do some. Okay, and your graph should look something like this. I know I've got this when I can graph piecewise defined functions, apply vertical and horizontal shifts to functions, and reflect graphs. So do you really understand? So describe the graph of the piecewise defined function. And then how is the graph of y equals the absolute value of x plus 1 related to the graph of y equals the absolute value of x? Well, in the first one, you would only graph the pieces of the line y equals x, where x is less than 0, and y equals negative 2x plus 6, where x is greater than 0, greater than or equal to 0. And then you can do that by plugging in those points for individual lines. How is the graph of this related? It is moved 1 to the left. I hope this helps. Please ask me in class if you have any questions.